Assalamu alaikum. Today we will discuss the balancing of redox equations. There are basically two methods to balance the redox equations. One method is the half reaction method, other one is the oxidation number method. But in this video we will discuss only half reaction method. By balancing the redox equations, we must make sure that number of electron lost by the reducing agent must be equal to the number of electron gained by the oxidizing agent. In both methods, it is carefully observed the loss of electron and gain of electron. By main advantage of half reaction method over the oxidation number methods, that half reaction method offers several advantages when studying the electrochemistry. First of all, second one is divide overall redox reactions into oxidation and reduction half reactions, which reflect their actual physical separation in electrochemical cells. In other words, half reaction methods very helpful to understand the electrochemical cell process. And half reaction methods need aqueous media, but aqueous media may be acidic aqueous media, may be basic aqueous media. Other advantage of this half reaction method, half cell method, that there is no need to assign the oxidation states of individual elements in the reactions. Okay, first we will discuss the balancing of redox reaction in acidic solutions. We take example of dichromate treated with iodide solution. Dichromate have a light yellow, strong yellow color, and when treated with iodide solutions, dark color is produced, in which solid iodine is present, that is dark brown in color, which is reflected in the solutions, and chromium ion is produced. Now we understand that how we can balance this equation step by step. Very easy method. First of all, divide the reactions into two half reactions. Dichromate ion change into chromium ions, and iodide ion change into iodine ions. In the first of all, we balance the dichromate ion into chromium ions. These half reactions. In second step, we balance the iodide ion into iodine. In the dichromate ion, the oxidation state of chromium is basically +6, and chromium on the product side have a +3. It means chromium is going from +6 to +3 oxidation state. Basically that is the reduction process, in which plus oxidation state is decreased to +3 oxidation state. It is due to the gaining of electrons. Next, we start the balancing of equations. Start from oxygen. On the reactant side, there are the 7 oxygen. To balance this oxygen, we put the 7 water molecule on the right hand side and product side. As a result, 7 multiplied by 2, 14 protons, 14 hydrogens produced. To balance these 14 protons, we put 14 protons on the left hand sides of the reactants. Now chromium, first of all, chromium is balanced. Chromium is 2 on the reactant side and 2 on the product sides. 7 oxygen on the reactant sides and 7 oxygen on the product side. And similarly, 14 hydrogens present on the product side and 14 hydrogens present on the reactant sides. After balancing the elements, atoms in the half fractions, now we balance the charges on the both sides. See that 1 hydrogen have a +1 charge, 14 hydrogen protons have a +14 charges, we put the +14. Dichromate have a -2 charges, put the -2. On the reactant side, one chromium has a +3 oxidation state, 2 chromium +6. It means product side have +6 charges and reactant side have +12 charges. How we can balance the plus charges on the both sides? We put the -6. If we put the -6 on the reactant sides, +2 and -6, and answer is +6. It means on reactant sides charge is +6 and product sides and on the +6. The digit which we have placed on the reactant side, that digit representing the electrons. We put the 6 electrons on the reactant sides. Okay. Second, we have balanced all the charges and as well as we have balanced all the elements on the both sides. Second one, in which iodide ion is changed into iodine. First of all, we balance the iodine, 2 iodine atoms on the product sides, and we put the 2 to balance the iodide ion on the reactant side. It means 2 iodines are present on the both sides, in which minus oxidation state is changed into 0 oxidation state. In other words, that is the oxidation process. In oxidation process, electron is lost. To represent the lost electron, we put the electron on the right hand side. Then we put the 2 electron on the right hand sides. Now in oxidation reaction there are the 2 electrons. On the reduction reactions we have already discussed the 6 electron on the reactant sides. But basic rule is that loss and gain of electron must be equal. How we can balance, how we can equalize the loss and gain of electrons? To balance this step, we multiply the iodide half fractions with the 3. It means when 3 multiplied with the 2, 6 electrons on the product sides. It means loss of electron and gain of electron are balanced. Loss, gain of electron and reduction process, and gain, loss of electron and oxidation process. Plus electrons are cancels. Now all the elements which are on the reactant sides put on the left hand sides, and all the products and of the oxidation half fraction and reduction half fraction put on the right hand sides. No equation is balanced.